Okay, in this video, I will explain from previous questions that I asked you to solve, if you still remember. From this example, I give you additional questions that I ask you to solve, which is find the resistance between surfaces R equals to RA and R equals to RB. Okay, instead of Z equals to 0 until Z equals to C. Okay, so I hope you already have solved this question by yourself, and this video you can check either your question your solution is correct or not. Okay, so first of all, in order for you to solve these questions, you need to know what kind of formula or equation that we will deal with. So the equation that we will deal with is the resistance equation, which is equals to minus integrations of E field dot dl over sigma integration of E field dot ds. Okay, so these are the formula, sorry, this is vector. So these are the formula that we will deal or we will use to solve these equations. All right, so first of all, okay, we need to decide what is the E here, E field here. So to know the E, okay, it is better to draw this diagram into 2D as we have done during for this example as well. I draw again this diagram in 2D. However, in this question, since that we are dealing with z-axis, so I draw the z-axis here and the electric field flowing here. So same with these questions, let's draw the electric field in 2D, and we should see, okay, we should see which axis is related with that electric field if for this diagram. So if we look here by logic, okay, by logic, the axis that we will deal with is x-axis and y-axis, and it will show to you like this, right? So this is our x-axis, this is our y-axis, and RA is this one, right? So RA is here to here, where this distance and this distance is RA, and then RB is from here to here, where this distance to this distance is RB, and this distance to this distance is RB. Okay, all right. Okay, now, so we can see here that electric field, okay, electric field that flow in this structure, okay, in this structure, it by logic, or I assume, again, I just assume that the electric field is flowing from here to here, which is from RA to RB, from the inner of the structure towards the outer of the structure. Okay, so the electric field can flow from here to here. Okay, in any pattern, it can flow in any pattern. It can flow like this, it can flow like this, it can flow in a straight line. So there are lots of patterns for electric field to flow. So what should we do is we should take the shortest electric field line that flow from RA to RB. So let's take a straight line. So straight line is always the shortest line. So the straight line will be 90 degrees to each other. 90 degrees to RA surface and 90 degrees to RB surface. Okay, and since that electric field is flowing from RA to RB, we can say it also, yeah, we can also say that surface of RA, okay, surface of RA is full with inner charges. Okay, surface of RA is full with inner charges, and we can say that surface of RA is full with surface charge. Okay, surface of surface, yeah, surface is only lies on here, yeah. So at the surface of RA, it's full with surface charge. Okay, surface charge. And also, if you can see, yeah, all this electric field line, this electric field and these charges, if we can converge it, if we can converge it, you can see that it is actually come from one focus point. It can be focused. Yeah? All this electric field and this charge, it can be focused at this point, right? It can be focused at the origin, okay, where at this point, at this point, and okay, in that case, we can say there is also possibility of line charge lies along z-axis. There is a line charge lies along z-axis which may also produce this electric field. Okay, so from here there is actually two sources of this electric field to be formed or to be produced. Okay, one is from the surface of RA. Okay, one is from the surface of RA. Another one is from the line charge which exists in z-axis. Okay, another one is from line charge which exists along z-axis. And since that the line charge is lies, we assume, yeah, it is lies or it is exists along z-axis, we can say that this line charge has infinity length. Okay, so when we can say that this line charge is having infinity length, we can use from our Gauss law, okay, E is equals to rho L over 2 pi epsilon naught R at R direction. Okay, so you can choose, yeah, now you can choose which mode of source that you want to deal with. Okay, which mode of source that can produce this electric field that you want to deal in order to solve this equation. Okay, so the easiest way to choose is by using or by assuming that there is a line charge lies on along z-axis where you can use this electric field equation and you can substitute this electric field in this equation, in equation number 1. So okay, so now I'm taking the easiest or the simplest way, which is I'm taking that there is a line charge lies on z-axis, and I will use this electric field to substitute inside equation number 1. So okay, so I can rewrite equation number 1 is minus integration of rho L over 2 pi epsilon naught R at R direction, and our DL, since that this is a line charge and the best or the suitable orthogonal coordinate system is cylindrical coordinate system, so the displacement for cylindrical coordinate system is dr at R direction. Okay, dr at R direction, right, over sigma integration of rho L over 2 pi epsilon naught R at R direction dot ds. So our ds, okay, is our charge sample area. Okay, so our ds is our charge sample area, and this charge sample area, which is the dq, yeah, dq is always 90 degrees to this electric field, and if we can look inside this diagram, electric field is flowing from here, right, from here, and 90 degrees to that electric field is supposed to be at this position, right? This will be our dq. Okay, so ds for this area of dq, okay, in R direction should be r d phi dz at R direction. Okay, and from here we can solve the equation where rho L over 2 pi epsilon naught can be cancelled to each other. Okay, and leaves to us this r can't be cancelled because there is dr here. Okay, so it will be 1 over r dr sigma integration of this r can be cancelled with this r, right? So there will be 2 times of integration, which is that because there is 2 variables here. One is d phi and one is dz. So what are the limits for d phi? So this is for d phi, integration for d phi, and this is integration for dz. Okay, now let's decide the limit. Okay, let's decide the limit for this 1 over r. Okay, so for this part, okay, for this part, if you can relate with our previous equation, okay, with our previous equation that we have solved here, if we take the limit, which is same direction with electric field, which is, for example, in this equation, we're taking the limit from 0 to c. So it is same direction with this electric field, right? So it will gives to you, if the limit is same direction with electric field, which is 0 to c, it will give you result of minus c. If you still remember from the video, from the correction video that I have made before. Okay, it will give you result of minus c. However, if you take the limit opposite direction with our electric field, for example, in this case, I said that the electric field is flowing from 0 to c. And if you take the limit, okay, if you take the limit opposite direction with electric field, which is from c to 0, from c to 0, okay, from c to 0, okay, so it will give you positive value. Okay, so this is by experience actually. Okay, this is what we look, or based from our previous calculation here. Okay, if the limit is same direction with electric field, it will give you minus answer. However, if you take the limit opposite direction with electric field, it will gives you positive value. Okay, positive value. So therefore, in this case also, since that I said that the electric field is flowing from RA to RB earlier. Okay, so in this limit, I should take the opposite direction with electric field in order to give our answer in positive. So I will put my limit here, opposite direction with electric field, so it will be from RB to RA. Okay, RB to RA. And for phi, the limit, I think by right you should know, same as our previous example, it is from 0 to 90 degrees because it is 90 degrees to each other, yeah, x and y. So phi is 0 to pi over 2, and z will be the height of this structure. So it will be from 0 until c. So from 0 until c. So if you solve this equation, okay, you will get ln RB over RA divide with sigma pi over 2c. And here you can simplify it to become 2 ln RB RA over sigma pi c. And this is, and don't forget the unit. So the unit is, since that we are calculating resistance, so the unit will be ohm. So this will be our final answer. Okay, so I hope, yeah, from here you already can have the picture how to solve this kind of equations. Yeah, so you can check with your solution either it is correct or not. And if you're correct, so it means that you already got the idea, the how to solve the equations. And if you got wrong, maybe you can identify where is your mistake. And if you have any questions that you want to ask to me, feel free to do so. Okay, so thank you very much, and see you in our next class. All right.